Hello students of class 11th. In this video lecture I am going to explain the proof of angle of friction equal to angle of repose, that is theta s is equal to alpha. Theta s represents the angle of friction and alpha represents the angle of repose. First of all, let me remind you what is angle of repose. Angle of repose is that angle which is at which the block which is kept on the inclined plane just start sliding down on the inclined plane. Okay, so suppose there is angle theta, on of inclination, and if there is a block which is kept on this inclined surface and this is angle theta and the block is not moving, and if we increase this angle theta by simply 1 degree, suppose this is angle theta, and if we increase this angle theta by 1 degree, then suddenly we observe that the block of mass m which is kept on the surface, on the inclined surface, starts moving down. So we can declare that angle at which the block moves down, start moving down on the inclined plane, then that is known as angle of repose. Okay, and now we will represent angle of repose as alpha, right? And if this block is of mass m, and we know that the weight will be mg, and this weight will act in the downward direction, means at the center of the earth. So now we will resolve this mg into the cos component and sin component. So before explaining the resolution, because we don't know which component will be cos component and which one component will be sin component, so let me explain this mathematics. Suppose this is a triangle. You know that this is mg. Mg is the weight of that block, okay, which is acting at the center of gravity of that block. This is the center of gravity of that block, and this is acting in the downward direction, means at the center of the earth. And we know that this angle is alpha, this is angle of repose. This becomes a right angle triangle, and this is 90 degree. So according to the rule that sum of all the angles of a triangle is equal to 180 degree, so this alpha plus 90 and plus this angle should be equal to 180 degrees. So for making this angle 180, for adding this angle to this 90 and alpha and making the sum of all the angles is equal to 180 degree, so this will be 90 minus alpha. This angle will be 90 minus alpha. Okay, when this angle 90 minus alpha, and we know that for the resolution both the components, sine component and cos component, they should be perpendicular to each other. So we don't know the cos component now, so that's why we are making this. And it is very clear that the angle between this component, means this component, and the horizontal and the inclined plane is 90 degree. This is 90 degree. This is 90 minus alpha. Then this will be, it is obvious that this angle will be alpha. Okay, so this angle will be alpha. So we can say that the cos component will be towards the angle, so it will be mg cos alpha, and the other component will be mg sin alpha. Okay, so this is very clear. Now see this, when the block starts moving down the inclined plane by the action of this mg sin alpha, then there is another force to resist this motion of the block in the downward direction, and that force is the frictional force, and this frictional force is represented by Fs. Okay, so it is very clear that mg sin theta at least should be equal to Fs. So that's why I have written equation number 1, Fs is equal to mg sine alpha. Okay. Similarly, the reactionary force by that inclined plane on the block is represented by capital R. This R and mg cos alpha are opposite to each other. So that's why we have written R is equal to mg cos alpha. This is equation number 2. And we got two equations based on this diagram. So when we divide 1 by 2, means if we divide equation 1 by 2, then we will get Fs upon R is equal to mg sine alpha upon mg cos alpha. Mg gets cancelled. So finally we will get tan alpha. So Fs upon R is equal to tan alpha. But we know that Fs upon R is equal to mu s. This is static coefficient of friction. So we can write mu s in place of Fs upon R. So this will be mu s is equal to tan alpha. Suppose this is equation number 3. This is equation number 3. Okay. And we also know that mu s is equal to tan theta s. So this is equation number 4. So based on this equation number 3 and equation number 4, we will get alpha is equal to theta s. Alpha is equal to theta s. Means we have proved this, that angle of repose is equal to angle of friction. Okay. We will start with the acceleration, proof of the expression of the acceleration of a body moving down on a rough inclined plane. Suppose there is a block whose mass is m, and this block moves down on the inclined plane, and suppose this is the condition that the angle of inclination is theta and that angle of inclination is greater than angle of repose, and then only this block will continue its moving down on the inclined plane. Okay, and this EB represents the inclined plane. Now, you know that in the last video lecture I explained you about the resolution of this mg component, that is mg cos theta, how mg cos theta we got, how mg sin theta we got, and how we proved that angle of repose is equal to angle of friction. In the last video lecture I explained this. Now in this video lecture there is no need to explain how we have resolved. So just I have indicated that mg cos theta will be opposite to the reactionary force which is acting on the block by this inclined plane, and mg sin theta is that force by the action of which this block comes down, moves down on the inclined plane. And it is obvious that when the block moves down on the rough inclined plane, then there will be the action of friction. And suppose that friction is represented by Fk. Fk is the kinetic friction. We are using kinetic word because kinetic means the motion, static means rest. So this is Fk. We are using Fk in place of Fs. Okay. So at this angle theta, which is greater than alpha, there is continuation of this motion in spite of this opposition of motion by this frictional force, that is Fk, means kinetic frictional force. Okay. Now by observing the diagram, we know that R is equal to mg cos theta. See, R is in the upward direction, mg cos theta is in downward direction. So it will be R is equal to mg cos theta. And if we talk about the net force will be in the downward direction. That's why the body is moving in the downward direction. Suppose the net force is F. Let net force is equal to capital F, and the body is moving in the downward direction. You know that how to how to calculate the net force. So net force F will be equal to, I am asking one question, that which one is greater, mg sin theta is greater or this kinetic frictional force is greater? Think about this. Pause your mobile for 1 minute and think about this. Now, by the action of this mg sin theta, this block is moving down. So we can say that, सीधी बात आप ये समझिए, मैं हिंदी में समझा रहा हूँ जिससे कि समझ में आ जाए, कि ये ब्लॉक इंक्लाइंड प्लेन पे नीचे की तरफ मूव कर रहा है. तो एक चीज तो बिल्कुल क्लियर है कि mg sin थीटा fk से ज्यादा होगा. mg sin थीटा जब ये fk से ज्यादा होगा, fk इज द ऑपोजिंग फ्रिक्शनल फोर्स फॉर दिस मूवमेंट, तो ये fk से ज्यादा होगा. तो नेट फोर्स क्या होगा? नेट फोर्स विल बी mg sin थीटा माइनस fk. होगा कि नहीं होगा? ठीक है. सपोज दिस इज इक्वेशन नंबर 2. ओके, दिस इज इक्वेशन नंबर 2. एंड वी ऑल्सो नो when this net force is acting down, then this net force can be equated to the product of mass and acceleration according to the Newton's second law of motion. According to Newton's second law of motion, F is equal to ma. We know that F is equal to ma. So put this F is equal to ma, put this in equation 2. So finally what we will get, in place of F we'll put ma. So it will be ma is equal to mg sin theta minus fk. ma is equal to mg sin theta minus fk. Okay, but we also know that fk is equal to mu k into r, means the frictional force is the product of coefficient of kinetic friction and the reactionary force which is acting on the block by the inclined plane. So in place of fk we can write mu k into r. So finally ma is equal to mg sin theta minus mu k into r. Okay, so we can take r is equal to, see the figure, we will use this equation number 1. So using equation number 1, that is r is equal to mg cos theta. Suppose this is equation number 3. Using equation number 1, r is equal to mg cos theta in equation number 3. So what we will get? It will be ma is equal to mg sin theta minus mu k. In place of r we are putting r is equal to mg. We are putting mg cos theta. So it will be mg cos theta. Now if you observe this, we can take mg as common. So it will be ma is equal to mg in bracket sin theta minus mu k cos theta. Gets cancelled, and finally we are getting the expression of the acceleration of a body moving down on a rough inclined plane as a is equal to g sin theta minus mu k cos theta. So this is the expression which was required to prove. So a is equal to g sin theta in bracket sin theta minus mu k cos theta. So it is very clear from this equation that a is less than g. Acceleration of a body down the rough inclined plane is always less than the acceleration due to gravity. Okay? Now, okay class, we are going to discuss on the topic work done in moving a body on rough inclined plane. So, suppose this is a body which is moving on the rough inclined plane and the weight of the body is acting in the downward direction. This is mg and the components are mg cos theta and mg sin theta. This is mg cos theta component and this is mg sin theta. This angle is theta. Okay. Now, अगर आपने मेरा प्रीवियस लेक्चर देखे हुए हैं तो ये कंपोनेंट का रिजोल्यूशन आपको बिल्कुल अच्छे से समझ में आ गया होगा, इसीलिए मैं फिर इसको नहीं समझा रहा हूँ. ओके, जैसे कि इसके पहले वाले प्रूफ में मैंने नहीं समझाया था इसी वीडियो में. नाउ द वर्क डन इन मूविंग अ बॉडी अप अ रफ इंक्लाइन प्लेन, वी हैव टू फाइंड द एक्सप्रेशन, वी हैव टू प्रूव द एक्सप्रेशन of work done in moving a body up the inclined plane. And suppose बॉडी ऐसे तो मूव करेगी नहीं जब तक कि उसको खींचा नहीं जाएगा. यहां पे अगर कोई आदमी है वो इसको खींच रहा है, ठीक है, तो हम P इसको इंडिकेट कर रहे हैं P. सपोज P इज द पुलिंग फोर्स एंड ड्यू टू दिस द बॉडी मूव्स अप. And if the body moves up by the action of this pulling force, then a frictional force, suppose it is indicated by small f, is acting opposite to this pulling force. Means जो frictional force है वो इस pulling force को oppose करेगा, ये नहीं चाहेगा कि ये ब्लॉक ऊपर खींचे. ओके, आप लोग ने क्लास 9th में पढ़ा था that work done, suppose W is the work done, work done is equal to force into displacement. पढ़ा था कि नहीं? This is displacement. Okay, and here P is the pulling force, so we can write P in place of this F, and in place of displacement we can write a small s. So W is indicated by work done. So W is equal to P into S. Okay, and we know that, see the diagram, P is equal to mg sin theta. So we can write mg sin theta in place of P. See, P is equal to mg sin theta because they are opposing to each other, so at least they should be equal. So that's why P is equal to mg sin theta. And also we cannot ignore this small f. This mg sin theta plus f are acting opposite to this pulling force. ये जो mg sin theta है और जो फ्रिक्शनल फोर्स है, ये दोनों पुलिंग फोर्स का अपोज कर रहा है. सी द डायरेक्शन ऑफ बोथ दीज mg sin theta एंड द फ्रिक्शनल फोर्स आर ऑपोजिट टू द पुलिंग फोर्स. सो पुलिंग फोर्स शुड बी द समेशन ऑफ mg sin theta प्लस f. ओके, नाउ इनटू s, this is W is equal to mg sin theta plus f in bracket, and out of bracket it is multiplied by s. But we know that F is equal to, means frictional force is the product of coefficient of friction and the reaction from the inclined plane. So it is equal to, F is equal to mu into R. Okay, and also R is equal to, चलो इसको बाद में डिस्कस करेंगे, पहले हम इसको F is equal to mu into R कर लेते हैं, वरना आप लोग कंफ्यूज हो जाओगे. सो F is equal to mu into R, तो यहाँ पे हम पुट कर देंगे in place of F we can write mu into R into S. So W is equal to mg sin theta plus mu R. In place of F we have written mu R. and out of bracket it is multiplied by S, and you know that, but we know that R is equal to mg cos theta. See, R is equal to mg cos theta. R is the reactionary force acting on the inclined plane perpendicular to this inclined plane on the body, and mg cos theta is the cos component of this weight of this block. So R is equal to mg cos theta. In place of R we can put mg cos theta. So W is equal to mg sin theta plus mu into, in place of R we will put mg cos theta, it will be in bracket into S. So work done W will be equal to, we can take mg as common, in bracket sin theta plus mu cos theta, and out of bracket S means displacement is multiplied. So in this way we got the work done, with the expression of the work done in pulling a block of mass m on a rough inclined plane which is inclined at angle theta. Okay, thank you very much for watching this video.